You should have done a little bit of a reading yesterday, hopefully, on the periodic table. And so this is our periodic table of elements. You're going to use this. There's a file within your Canvas where you can see the periodic table. And when you're here, I have one that you can utilize here. So anything that we do from this point on, you're going to need access to the periodic table. So if you want to take a copy home to leave, if you're working at, to have a paper copy at home, that's fine. So periodic table is just a table of elements. It's going to be ordered by atomic number and based on chemical properties. So hopefully from the reading, you got a lot of this information or the several different activities. Groups on the periodic table are your vertical columns. So if we use this one up here, any column this way, these are groups. They are going to tell you this group number at the top is going to tell you the number of valence electrons. And valence electrons are the electrons that are in the outermost shell of the atom. And so on yours, it's the number that has an A beside it. So column 1, group 1, has 1 valence. Group 2 has 2 valence. We skip the B group here in the middle. And then you have 3A, which starts with boron. They have 3 valence electrons. Then 4 for the next group that starts with carbon. The next group that starts with nitrogen has 5. Next with oxygen has 6. Then 7. And then 8. The very last column, they are stable. They do not want to make any compounds because 8 is sort of the magic number. They're stable if you have 8 valence electrons in the outermost energy shell. And if you're in the same group, the same column, you have the same properties. So the number with the letter A tells you valence electrons. Very, very important. What we do tomorrow, you'll need to use that. Here are the names. You need to know group 1, which is alkali metals, most reactive for metals. They are the most reactive metals. And group 2, alkaline earth metals. They are also very reactive. We don't do a lot with the middle section here, group 3 through 12. We just call them transition metals. They're your most common ones that you're familiar with, and they do a lot of very interesting things with their electrons. So in things that we do, we kind of leave them alone there in the middle. Group 17, halogens, you need to know that. These are your most reactive nonmetals. They will like to react with group 1 and form compounds. That's how we get salt, sodium, and chloride. And then group 18, your noble gases, most non-reactive. They are very stable. So those are the main ones you need to know. Group 1, 2, 17 or 7A, and 18 or 8A are the ones that you need to know be able to recognize their names. And here it is just labeled. And I'll post the PowerPoint separate from the video so you can use it to reference. Periods go left to right, so straight across. The first period only has hydrogen and helium in it. And then the second period starts with lithium, beryllium, skips the middle, goes to boron, all the way through neon. These tell you the number of energy levels. This is going to come important tomorrow with what we do. So it's the number of circles we're going to draw around an atom where we're going to find the electrons. So this is going to, right here, the different levels. The one closest to the nucleus will only hold 2 electrons. Level 2, the next one out, can hold up to 8. And level 3 can hold up to 8 for what we're going to do. And we don't really deal much with level 4. So again, here's an image that shows you the different energy levels. So if you're in period 1, you have 1 energy level. Period 2, you have 2 energy level. Period 3, you have 3 energy levels. And we usually do not go past calcium here if we are drawing models of atoms, because then they get more complicated. So here is an image, and we're going to really look at this tomorrow, of how to draw models like this. And so magnesium here is in period 3. So it should have 3 circles around the blue nucleus, and it has 3 black rings. It is in group 2. So on the very last ring, there should just be 2 circles that are red. Those are your valence electrons. And so then you know that first level only has 2, so 2 electrons. Second level holds up to 8. There has to be 8 there if there's a third ring. And then since it's in group 2, there's only 2 here. So its protons, atomic number is 12. That means I should have 12 electrons. So I have 2 plus 8 is 10, 11, 12. You always indicate the number of protons and neutrons in the center. And so we're going to really look at that tomorrow. Let's see. In the reading, I think that you did yesterday, you read about metals. You need to be able to pick out some of the characteristics of metals. On this table here, they're the ones in light blue. They tend to be shiny, silvery solids, good conductors. Malleable means they can be hammered into sheets, like sheets of metal. Ductile means they can be drawn into wire. And they're always described as left of the metalloids, which is these orange ones here, left of the metalloids. Nonmetals are right of the metalloids. They're purple here, with the exception of hydrogen. Hydrogen is unique. It's there because it has 1 valence electron. Gases, they tend to be gases, or if they are solids, they're kind of dull and very brittle. They do not conduct electricity well. And then hydrogen is the oddball that's over here. Then we have metalloids, which are here. And depending on the periodic table you look at, some bring it on down to these 2 here, and then some stop it here. So depending on the periodic table you use, but usually they'll be indicated which ones, usually with a bold zigzag line. And they're going to be solids. They are your semiconductors, very important here. And sometimes they act like metals, sometimes they act like nonmetals. So that's why they're kind of metalloids. They're kind of a mixture in their behavior. And that's where we're going to stop today, because tomorrow we're going to pick up on drawing